Data analytics is the foundation of AI. Without understanding data, you can't understand or trust the intelligence built on it. This video course is introductory to data analytics for the age of AI. Created by Dr. K. Seefeld. The material used in these videos is in the Text Data Rookie's Introduction to Data Analytics. Available as a free PDF from the website www.dataanalyticscurriculum.com. Chapter 2: Understanding Data. Understanding data is foundational for data analysis, machine learning, and advanced data processing. The structure, type, and organization of data impact how it can be processed, analyzed, and used for decision-making. This section covers data types, structured versus unstructured data, and how structured data is manipulated. Welcome to Chapter 2 Section 1, Types of Data. In this lesson, we'll look at the different categories of data, how they're used, and why understanding them is important for analysis. Learning outcomes. By the end of this section, you'll be able to do 4 things. First, you'll understand the difference between quantitative and qualitative data. Second, you'll be able to recognize the 2 subtypes of quantitative data, discrete and continuous. Third, you'll be able to identify the subtypes of qualitative data, nominal and ordinal. And finally, you'll understand what unstructured data is and how it's different from the others. Quantitative versus qualitative data. All data can be grouped into 2 broad categories, quantitative and qualitative. Quantitative data is numerical and measurable, while qualitative data describes qualities or characteristics. Each type serves different purposes and often requires different ways of collecting, processing, and analyzing the information. Quantitative data. Let's start with quantitative data. Quantitative data involves numbers. It represents measurable quantities and can be used in calculations and statistics. There are 2 main subtypes of quantitative data, discrete and continuous. Discrete data. Discrete data consists of values that can be counted, whole numbers only. For example, the number of students in a class or the number of products sold in a day. You can't have half a student or a fraction of a product. Discrete data is all about countable quantities. Continuous data. Continuous data, on the other hand, can take on any value within a range. It's measurable and can include decimals. Examples include height, weight, time, or temperature. Unlike discrete data, continuous values can be infinitely precise, like saying something weighs 3.26 kilograms or takes 12.47 seconds. Quantitative example. Here's a quick example. Sarah owns a cafe and analyzes her sales data. The number of customers who visit each day, for instance, 85 on Monday, is discrete data. The amount of coffee served, like 8.5 ounces in a small cup, is continuous data. Qualitative data. Now let's move on to qualitative data, which is sometimes called categorical data. This type of data describes qualities or characteristics, things that can't be directly measured or counted. Qualitative data helps us categorize or label information rather than measure it. Nominal data. The first subtype of qualitative data is nominal data. Nominal data consists of categories that have no specific order or ranking. Examples include gender, nationality, or color. In these cases, one category isn't greater or less than another, they're simply different. Ordinal data. The second subtype of qualitative data is ordinal data. Ordinal data has categories that can be ordered, but the differences between them aren't necessarily equal. For example, ratings such as poor, fair, good, very good, and excellent have a clear order, but the distance between each isn't consistent. Education levels, like high school, bachelor's, and master's, are another good example. Qualitative example. Here's another example. Doug manages a restaurant and wants to understand customer preferences. The type of cuisine his customers prefer, say Italian, Mexican, or Chinese, is nominal data because the categories have no order. Customer satisfaction ratings like poor through excellent are ordinal data because they do follow a sequence. Unstructured data. Now let's look at unstructured data. Unstructured data doesn't have a predefined format. It's usually qualitative and includes things like text, images, audio, and video. Because it doesn't fit neatly into tables or spreadsheets, it takes more advanced techniques to analyze. For example, natural language processing is used for text, and image recognition is used for photos and videos. Unstructured data example. Imagine Emma, who collects thousands of social media comments, tweets, and product reviews. Her data includes text, emojis, pictures, and even short videos. All of that is unstructured data. Some of it might include numbers, but overall it doesn't have a consistent structure and needs specialized tools to interpret it. So, to recap, data can be quantitative or qualitative. Quantitative data is numerical and can be discrete or continuous. Qualitative data describes characteristics and can be nominal or ordinal. And finally, unstructured data doesn't follow a fixed format and often requires advanced methods to analyze. Understanding these types of data is the first step in knowing how to collect, clean, and analyze information effectively. Remember, the book is available as a free PDF download, and if you need hands-on labs, there are additional books with these to accompany the text, as well as other books and resources available at the website www.dataanalyticscurriculum.com.